So this week we're going to be going over data types, variables, and operators in Python. So really the core functionality of any programming language is the base variables and the base data types that you can use and operate on without throughout your programs. Every piece of code that you build is going to consist of some form of variables, some sort of data types, and some sort of operators. So this is the absolute foundation of any programming language for those of you not familiar. So to start off, there are a few core data types, and one of them is a string. So strings are arrays of bytes representing Unicode characters. They're basically text. The built-in function for a string is str, just str with the parentheses after. Just a quick note, any function should have parentheses following it. So if you're going to use like a built-in function version of anything, the print function, which I showed a little bit of last week, that had the parentheses after. So if you're using the string built-in function or str, you would put the parentheses after. Some examples of strings are all these different versions of Hello World. So just some things to call out here in Python. You can use single quotes, you can use double quotes, and you can even use triple double quotes or triple single quotes. There's not really much of a difference between these two, but there is a difference between the first two and the second two. The first two, there's not really much of a difference. Second two, not much of a difference. The thing here is you might want to use a single quote in a case that, say, you have to use a double quote inside of your string. So say you're putting some string where you're quoting somebody in it and you want to use double quotes inside of that string, then you might use a single quote there. And you might use the double quotes in the case that you have like an apostrophe or something, like you're using a possessive because somebody owns something in that sentence. You would want to use double quotes in that case. The times that you'd use triple quotes, these are typically for multi-line use cases. So if you ever have a situation where you want to have multiple lines of a string without having some complexities of trying to get your of trying to combine your parts of the string after the fact, or there's certain ways you can do it. You can make a continuation of a string using certain characters, but it gets complicated. And the triple quote will allow you to have multi-line strings, and that goes the same that's the same case for triple single quotes essentially. So the two down here, the bottom two, are basically for multi-line use cases, and then the top two are for single line use cases generally. Another advantage to the triple quotes or to either of the triple quoting options is that you can have a double quote or a single quote inside of those. So if you also have a use case where, say, you're quoting somebody and they used a possessive in there where they say something about, like their quote, they say that someone owns something or whatever, and so there's the possessive apostrophe in there. Maybe you'd want to use a triple quote in that case, so you don't have to escape one of the quotes that exist inside of your string. And we'll see some examples of that stuff later on. And just stop me anytime if you have any questions. The chat would be ideal. I'll keep an eye on the chat, but if you want to just call anything out, just feel free to interrupt me and I can.
Yeah, David, maybe before we proceed, just a question on the parentheses.
Sure.
I'm always intrigued how you insert it very fast. Is there a shortcut to it, or I'm jumping ahead?
Oh, so so oftentimes in PyCharm actually. So great question. So PyCharm will actually it can tell what you're trying to type. It knows, you're trying to type the print function or something, and it'll give you a suggestion down there that you're, of like, oh, maybe you're trying to put in print, and then you can just hit enter there and the parentheses will automatically be inserted. But then there's also just the fact that, I've been programming for years now. So it's, reaching those keys is pretty natural for me. But trust me, at the beginning, there are certain keys when programming, like any of the brackets or any of the parentheses or special characters or anything like that. It just takes some getting used to. And it's just like anything else, when you first started typing, maybe it was like search and find everything, and now you feel more comfortable typing around on a keyboard. That's kind of the same case with any of these special characters in programming. But yeah, great question. Thanks. So the next core data type in Python is an integer, or they're various forms of numbers. So there are three primary forms of numbers in programming. There's an integer, which are whole numbers, just like in math. The built-in function for integers is int with the parentheses after it. And some examples of integers are like 1 or negative 100, 1,337. Basically just calling out here. You can have positive, negative, or zero values of integers. Just there's not going to be any decimal places or anything after that. So the next one is a float. So if you do need to have a decimal number, you're going to be using a float. The built-in function there is float with the parentheses after it. Oh, my bad. Let me go back. So the built-in function there is float. Some examples of a float are like 1.25. You have the decimal place there. You can also use scientific notation if you're more comfortable with that. So this is negative 1,337, but with scientific notation, you can do the e to the 2. So this is like 13.37 times 10 to the second power is kind of how you can read this. So because we're using a decimal there, this is still considered a float. But if you evaluate this out all the way, it could also be an integer. But because I wanted to use decimal here, or because I wanted to use scientific notation, it had to be a float. And then here again with the e, this one is 0.001. So this is like 1 to the 1 times 10 to the negative third power. But this could also be written as 0.001, just trying to show multiple ways that you can create floats here. Only use scientific notation if you're comfortable with it. You don't have to by any means. I just wanted to include that option there for anybody who's in any scientific use case, and it might be beneficial to use scientific notation. And then finally, we have complex numbers. Complex numbers are imaginary numbers. For those of you familiar in math, this is typically denoted with the I in math, but where I is the square root of -1. So the built-in function for that is complex, and it has parentheses after it. In Python, though, and this is a little unfortunate, but you use J for that complex imaginary number. So this would be like 5J or -2.2J. It's very rare that you're going to be using complex numbers. I just wanted to call out that it's a possibility. But if you're doing any really complicated math use cases where imaginary numbers are involved, now you know how to get an imaginary number in there. It's a complex number. The two that you're primarily going to be using are integers and floats. Will rarely, if ever, use a complex number. All right, so the next core data type is a Boolean. So Booleans are binary values. Binary meaning they can only have one of two values. In this case, it's either true or false. The built-in function is bool, and there are a number of examples of Booleans. So of course there's true, note the capital T here, and false, note the capital F. If you try to type out lowercase true or lowercase false, you're gonna see some errors about like, oh, true isn't defined, and it should be a built-in value, right? Because it's one of the core data types in Python. The reason you might see that error is because you need to make sure that you use a capital T, the rest lowercase, or a capital F, the rest lowercase, when you create a Boolean value. So just keep that in mind. You can also create Boolean values by doing using logical operators. We're going to talk about operators here in a bit, but 5 greater than 6, this creates a Boolean value. This evaluates to false, because 5 is not greater than 6. So this is still a Boolean value here in the back end of Python. It'll be evaluated as a Boolean value. Same with x is equal to y, the double equal sign, we'll talk about it in a moment, but that assesses equality rather than assignment. But if x is equal to y, if they're both holding the same value, then this would evaluate to true. If they aren't both holding the same value, then this would evaluate to false. Either way, it's still going to evaluate to a Boolean value. It'll evaluate to true or false. So I know Booleans can be a little weird to wrap your head around at first, but it's something that's going to be pretty integral to Python or coding in general going forward. Any questions on it before I move on to the next slide? All right, great. So so those are the real core data types of Python, and then we can get into variables. So variables are containers for storing data values. It's basically a means to store some value in your program, and then you can create a reference. And then you can reference that value throughout the rest of your code once you've created that variable. Now, the nice thing about variables is you assign it once, use it 100 times or more. The best thing there is if you create a value, and then you don't have to keep typing it out again and again and again. And the big benefit to that is that you don't have to, if you have to change that value, like say, we create a very, we're trying to store hello world, and say I misspell world, I spell it WROLD or something. If I typed out hello world 100 times in my program and misspelled it every single time, then I need to go through and change all of those instances of that misspelling. But if I stored in a variable, like say greeting, then all I have to do is change that spelling mistake in the single greeting variable, and then it's changed. And then that, because that value is referenced throughout the rest of my code, it's going to be changed basically throughout the rest of my code. So that's the huge advantage to variables. So you can declare a variable by assigning it a value using the equal operator. So the single equal sign is an assignment operator. Yeah, so the single equal sign is the assignment operator. I mentioned in a previous slide that the double equal sign is a equality operator. We'll talk more about operators in a minute, but important things to note here is that you always have your variable name on the left side. No quotes or anything surrounding it because it's going to be a variable, so you don't want to put any quotes around it. Then you have the assignment operator, and then the value you want to assign to it. So this is where you would use some data type or data structure here. So so in this case, I'm creating a variable named greeting, and I'm assigning to it the string hello world, and note I'm using the string with single quotes here. So hello world is my greeting. And now later on in my code, I can reference greeting wherever, basically, and it would have a reference to that hello world string. And then here I'm, assigning some integer values to X and Y. Something to note here is that on a single line, I can assign multiple values. So I can assign X equals 5 and Y equals 12.0 on the same line. So this one's an integer, this one's a float, because I included the decimal, even though it could be an integer. So I misspoke a moment ago. These aren't both integers. This one's an integer, this one's a float. But I can assign two variables on the same line by just separating them by a comma. This comma is extremely important to use when you're separating, if you're assigning on the same line. Generally, assigning on a single line isn't best practice, but just know that you can do it if you really need to. That's why I wanted to call that out. Another thing here, yes, no. So, this is going to be a Boolean value because I'm assigning it to a Boolean function is what this is called, basically, when you do something like this. So, if X is less than Y, then this will evaluate to true. Otherwise, it'll evaluate to false. And the value stored in yes, no will be true or false. So, so that's one way that you could assign a Boolean. Another thing that you can do here is I can assign Boolean to bool, to the function bool, and now Boolean is the function bool. Generally this is just creating an instance of a bool, but I haven't given a value to that Boolean yet. So right now it's just kind of it knows it's a Boolean. Is it true or false? Who knows yet? We haven't assigned a value. But just a number of different ways that you can assign variables. This one basically is to call out that you can assign a function to a variable here. So variables are going to be critical to your coding going forward. Any questions on that? And it looks like I'm just going to respond to someone in the chat. It looks like they're having issues hearing me. And I noticed another question in the chat. I've noticed that once we have written a line on Python, we cannot modify it. So that's the case in the REPL environment. Once you write a line of code in the REPL environment and hit enter, you can't go back and modify that line of code. But if you're writing the code in a file, you can. If you're writing the code in a file, then you can easily go back and edit that that line. So generally when you're practicing, it's good to try things in the REPL environment, and then if you need to make a change to it, it'll just print out an error, and then you can always hit up on your arrow key, and that'll bring back the line that you typed previously. You can edit that line there and then try it over again. So that's one way you could proceed in the REPL environment. But otherwise, if you're writing it in a file, then you can always change whatever lines in a file. A file is always going to be editable. It's just the REPL environment where previous lines of code you wrote won't be editable. And I'll show that a little later on. Great question, though. And then in the assignment, bool, can you give other statements like yes and no, and how do you do it? So we can give other statements like yes and no. So one thing you could do is maybe you would create a variable yes, assign that the value true, create a variable no, assign that the value false, and then reference yes and no throughout your code. But at its core level, a Boolean value can the only thing it can hold is true or false, which is similar to like 1 and 0 respectively. So you can't assign it different values, but you can, logically in your head or logically throughout your code, you can think about, yes being true and no being false, and things like that. And you could assign those values to variables, and then you could use those variables throughout your code if that's easier for you to conceptualize. Great questions. If there are any more, feel free to put them in the chat. Should the greeting have both words in capital letters or not? So great question. It's really up to you. For me here, I want to say, I'm just trying to say hello world. I'm not considering world a proper noun here, but if I was saying hello David, like a greeting to myself or a greeting to any of you, like hello Patricia or anything like that, I would put the second word. I would capitalize the second word. The thing about strings is they're extremely flexible. There's not going to be an error. As long as it's a valid string, there's not going to be an error. And a valid string can have any combination of uppercase, lowercase, whatever. Like I could have started this with a lowercase h. I could have every other letter done uppercase. I could have done, none of them uppercase, all of them uppercase, anything like that. Strings are really flexible in that sense. Yeah, so it's really up to you, basically. If you wanted to capitalize world, if you consider world a proper noun, sure, you definitely can. Or if who you're greeting, like if you're greeting a person, you would want to capitalize that. But then we're kind of getting into like grammar and the syntax of a language, right? So it really depends on your use case and what your string is trying to hold, what you're trying to represent, and how important it is to you to have that proper language syntax, because a string can just hold words and letters from any other language. They don't necessarily mean anything to Python, but they would mean something to us, right? Like saying hello world means something to us as humans. We're saying hello to the world, right? But it doesn't necessarily mean anything to Python. So it's not going to be a problem if you misspell something or if you choose to capitalize in some different way. Great question. Yeah, keep them coming in the chat. I'm just going to move on to the next slide, but if you have any others, please throw them in the chat. All right, so now on to operators. So starting first with the arithmetic operators. So arithmetic operators are just like they sound. They're related to arithmetic. They're related to math, basically. In this column, I have the operator. This column, what it means. It's kind of its name. You'll hear this as the name like oftentimes, and then an example of how you would use it. So in this first column here, we have plus. So this is a plus sign. Its meaning in the arithmetic sense is addition, and there's a reason why I'm calling out in the arithmetic sense. We'll get back to that in a moment. You'll see why. But its meaning in the arithmetic sense is addition, and an example is just 1 plus 2. This would evaluate to 3. If you put this in your REPL environment, you'll just get 3 spit back out. The minus sign, it's a subtraction operator. So 1 minus 2, put this in the REPL environment, you're going to get -1 output. The star, so the star is how you do multiplication. It's not like an X or anything. It's the asterisk or star. It's the multiplication operator. So 1 star 2 is the same thing as 1 times 2. This is just going to evaluate to 2. So if you put it in your REPL environment, you'll get 2 output. Slash, this particular slash is used for division. The other slash is an escape operator. We'll talk about that down the line if it's ever needed, but don't worry too much about the other slash. Just know that this slash is for division. So you would write it 1 slash 2. This evaluates to 1 divided by 2 or 0.5. So that would evaluate to a float there. Well, actually, we get into some complicated things with using the slash with integers. Just be careful if you're doing something where you want to make sure that you have decimals. It's always best to, like, if we wanted decimals here, to have 1.0 divided by 2.0, that'll output to 0.5. If we do 1 divided by 2, you might see some weird behavior. Play around with it. It's odd. You'll get used to it with time. But anyway, the percent sign is used as this is called the modulus operator. This one is pretty difficult to wrap your head around, but overall it's probably the most complicated operator. But what it essentially means is you take the remainder of that division. So you do the division, but then your result is the remainder. So this one up here, you're taking the so this one up here, the division one, you're saying 1 divided by 2, and I want the result of that division. For the modulus operator, you're doing 1 divided by 2, but I want the remainder of that division. So the remainder here, since 2 is larger than 1, the remainder is going to be 1. If you had, say, let's say 5 divided by 2, 2 fits evenly into 5 twice. So the remainder after that is 1. So 5 modulus 2 is going to be 1. This is a great operator to use if you want to figure out if something is a divisor or a factor of another number. So if you're trying to determine, is 324 a factor of 1526, you can use the modulus operator. And then if anything spit out, then you know that no, it's not, that the first number is not a factor of that second number that I mentioned. I probably should have written them down because I can't remember which ones I said right now. But if 0 is spit out, so if, say I do 4 modulus 2, so I want to know the remainder of 4 divided by 2, I'd get 0. Oh, that tells me that 2 is a factor of 4. Modulus is super helpful in a number of situations. I highly recommend spending some time reading about it or doing some exercises on W3 schools, which I'll give at the end of the course. But if it doesn't make a ton of sense right now, that's expected. I'll show some examples at the end of the course here. So I noticed some questions I'll finish the slide and then I'll get to the questions actually. So double star here, double star is exponentiation. So it's like, a to the power of b or whatever. So in this case, I'm doing 1 to the power of 2. So 1 double star 2 is 1 to the power of 2. Of course, 1 times 1 is just going to be 1. But say if I did 2 to the power of 2, this would evaluate to 4. So if you ever have an exponentiation use case, double star is the one you want to use. Of course, you could, also do something like, chaining together your multiplications if you wanted, but exponentiation is going to be the faster way to do that. And then the double slash is floor division. So this won't, so using floor division won't return any of the remainder or anything. So here where I have one floor division 2, this is going to evaluate to 0. Because one divided by 2 is 0.5. We floor that to the next integer, and then we get 0 basically. So if you ever have a use case where you don't care about the decimals there, you want to make sure that you end up with an integer at the end, use the floor division operator, which is the double slash. Great. So some questions that came up in the chat. Did we have to keep the space between the number or not? Great question. No, you don't have to keep the spaces here if you don't want to, but it is best practice to do so. It's a little bit easier to read. Something that you'll find with Python is, or coding in general, not just Python, is that you're going to read a lot more code than you're going to write. Of course, right now when you're starting out, you're going to be writing more code than you're reading. But if you ever get into a professional environment, you're going to be reading code very often, and you want to make sure that you're writing readable code so that when you have to come back to it, you can easily look over that code and know exactly what you were doing. So so always keep in mind when you're writing code, try to keep it clean and readable. So in that case, having the space between numbers does make it that much more readable, especially when you have like a complex math equation. They're not required. Python's not going to reject your code or anything like that if you don't include the spaces, but just keep in mind that it would be easier for you or somebody else to come back to it and read it and understand what's going on later on if you do include those spaces there. So great question. Thank you for the question. Another one. So 1 modulus 2 is equal to 0. So no, actually, 1 modulus 2 is going to be equal to 1 because, how many times does 2 fit evenly into 1? It doesn't. So you just take the whole number of 1 because, 1 divided by 2, the remainder after that is still 1. So you want to think of it in terms of how many times can the second number, the number to the right of the modulus operator, how many times can it evenly fit into the first number, and then what value would be left over after taking out, however many times that number can evenly fit into that first number. So say we're doing 10 modulus 3. How many times can 3 evenly fit into 10? 3 times. So what's 10 minus that 3 times 3? So 10 minus 9, 1. So we end up with 1 as our value there if you do 10 modulus 3. But if you did 9 modulus 3, 3 evenly fits into 9. So you would end up with 0 at the end as your value there. And we'll go over that in a moment. I highly recommend, though, just practice it. Just try it out. Try it with a number of different numbers, and it'll start to make a little more sense once you practice it yourself. But trust me, it is very confusing. So if it's hard to wrap your head around, don't beat yourself up. It's probably the most complicated operator. There are some other ones, but it's the most complicated operator that you might actually use. I'll put it that way. All right, another question. Can you please give examples when modulus operator can be useful? Yeah, great question. So oftentimes the modulus operator is useful when you're just trying to figure out something like, is the number, so say you ask somebody to input a number, and for some reason the logic of your program is dependent on, is the number even or is the number odd? So if you want to figure out if a number is even, and we're getting kind of deep into math theory here, but in math, if you want to determine if a number is even, you would divide that by 2, and if there's any remainder, it's not even. If there's no remainder, it's an even number. So say you did, say you want to figure out is 1024, is that an even number? Modulus that by 2, you're going to get 0. So 1024 is an even number. But if someone inputs, 1025, that's going to be an odd number because it's going to, 1025 modulus 2 is going to evaluate to 1. So one of the most common use cases for the modulus operator is determining whether or not a value that you have is even or odd. There are other use cases. There's this one programming challenge called FizzBuzz, and the FizzBuzz challenge is basically like, so if a number is even, output this value. If a number is odd, output this value. And if a number is evenly divisible by 5, output this other value. So it's more that's more of like a coding challenge, you know, approach. But yeah, hopefully that helps. So when the answer is 0, do we just write the right? So when the answer is 0, and I'm assuming you mean modulus here. So not quite. So if the answer is 0 from a modulus question, that just means that the first number is evenly divisible by the second number. You don't necessarily have to write the number to the right or anything like that. All that really means is that they're evenly divisible. Your code's logic can do whatever you want based on that finding. So yeah, I hope that helps. Any other questions, please feel free to throw them in the chat. These are great so far. You know, I'm loving all the questions. Chances are if you have a question, somebody else has that same question. But one thing to that last question, if and maybe I had misunderstood initially with modulus, if the answer is 0, so like in this case 2 goes into 1 0 times, then the answer is the number to the left. So if I'm trying to do, you know, 5 modulus 7, well, 7 doesn't go into 5 at all, so that evaluates to 5. So in that case, the answer is whatever is on the left. If the number on the right is larger than the number on the left, then the answer is going to be whatever is on the left. Perfect. Okay, yeah. Sorry, I misunderstood your question at first. I'm glad I was able to come around to it. Awesome. Yeah, thank you for the questions. These are great. Please keep asking if you have any. In the meantime, I'm going to move on to the next slide. So assignment operators. So we already talked about the equal sign, the single equal sign being an assignment operator. An example is x equals 5. It's the same as x equals 5. You'll see why the same as is pertinent later on. But there are other assignment operators that you can use, like plus equals. So the plus equals operator, an example of that is x plus equals 6. So there, what we're saying is we take x and assign it to x plus 6. So it takes whatever value is currently stored in 6 and adds 6 to it, and then assigns that back to x. That's essentially what's happening with the plus equals operator. So this is beneficial in cases where you don't want to write out this longer formula. You can just simply do x plus equals 6. And then we have, you know, basically for all the rest of our operators that we talked about on the previous slide, we have a similar blank equals that you can do that with. So minus equals, x minus equals 2 is the same as x equals x minus 2. So these operators, as you go down here, they're really a shorthand for whatever is in the same as column. So we could do, you know, times equals x times equals 2 is equal to x equals x times 2. So let's actually go through and assume that we're just going to assume that x is equal to 5 in all cases. So here, when we use the plus equals operator, if x is already 5, x plus equals 6, now the value stored in x is going to be 11. So because if you think about it here, we have x equals 5 because the value currently stored in x is 5, x equals 5 plus 6. So you end up with 11, and that's what's stored back in x. Now going back to x being 5, minus equals, so x minus equals 2, where after this is evaluated, what's stored in x is going to be 3, because you took x equals the current value of x, which is 5, and then subtracted 2. And now you have 3 stored in x, because that's assigned back to x. Times equals, x times equals 2. So x times equals 2 would be, you take the current value of x, multiply it by 2, and assign that back to x. So that would evaluate to 10, because here you would take x equals 10 times, or 5 times 2, and you end up with 10. Is there a question? Okay, great. Yeah, I just heard some background noise, but perfect. Divide equals, x divide equals 2, assuming we have 5 here. You know that you're going to end up with about 2.5. in that number, because you take 5 divided by 2 and then assign that back to x, and now the value of x is 2.5 modulus equals. So we have 5 stored in x. So 5 modulus equals 2. Now 1 is going to be stored in x because 5 modulus 2 evaluates to 1, and you store that back in x. And that's what is that's what's going on there. Floor division, so x floor divide equals 2. You take x, so x is currently 5. Floor dividing there is going to be, you're going to end up with 2 instead of 2.5, because 5 floor divide by 2 is 2, because you don't want that decimal place in there. So the value stored in x after this evaluates is going to be 2. And then exponentiation equals, so x exponentiation equals 2. You take 5, raise it to the second power, store it back in x. So now x is equal to 25, because it's basically the same thing as taking 5 to the power of 2. 5 squared is 25. Store that back in x. Okay, so go into the chat for questions. Why are there x's all over the place? Can't y be used instead of x equals x plus or minus and something else, because it appears that x already has a value? So great question. Yeah, you can use y if you want. So the thing here, the reason I'm showing this is because x does already have a value, but the assignment operator, whenever you're using an assignment operator that's not the basic, just single equals sign one, the number already has to have a value in it. So when you do x plus equals 6, you're taking the current value of x and then adding 6 to it and then storing it back in x. So that's why we have x equals x plus 6. In this case, the same as here wouldn't work if I couldn't say that x plus equals 6 is the same as x equals y plus 6, because it's not the case. It's taking the current value of x, adding 6 to it, and then storing that back in x. So while x does already have a value, this is like modifying. These ones down here all modify the existing value of that variable. So I hope that helps. But any variable, the variable name, there's very few variable names that you can't use. So they can't start with a number, and there are certain keywords in Python that you can't use. PyCharm will have them show up as like an orange or a purple color. You'll know if it's a keyword argument, so you can't use certain keywords. But otherwise, your variable name could be anything. So if we wanted to substitute on this whole slide every x for a y, that's totally valid. Or every x for my variable, totally valid. Of course, my underscore variable can't have spaces in variable names. Another little thing there, but yeah, I hope that helps to answer your question. All right, so does it mean the value of x will change after the operators has changed? Yes. So that does mean that the value of x will change. So when I'm using the plus equals operator, I'm reassigning the value of x in this case. So if I use x plus equals 6, I take the current value of x, add 6 to it, and then store that back in the variable x. So if x equals 5 to start, and then I do x plus equals 6, this is going to evaluate, this evaluates to 11, and the value now stored in x is 11. So if we kind of go down this whole thing here, and this might get a little complicated, but we start out with x equals 5. Then we do x plus equals 6. Now x is 11. Then we do x minus equals 2. Now x is 9. Then we do x times equals 2. Now x is 18. Now we do x divide equals 2. Now x is back down to 9. Then we do x modulus equals 2. Now we end up with 1, because 9 modulus 2 is 1. And so the value of x is now 1. And then x floor division 2, that's going to evaluate to 0, because x was 1, and floor dividing by 2 makes it 0. Now and then now x exponentiation equals 2. That's going to be now it's still going to be 0, because 0 to any power is 0. I hope that helps. So if you kind of follow this down, X changes like constantly throughout these are reassignment operators. It's a way to assign while also doing some sort of arithmetic on your variable. Great question. Great. So if there are any other questions, please throw them in the chat. This has been awesome. I love all the questions. But I'm going to move on to the next slide for now. So assignment operators continued. This is where they get a little complicated. Don't worry too much about this side, about this slide. We have and equals, or equals, exclusive or equals, and then these are bitwise shifts. I'm not going to spend much time on these. You'll almost never use these. I just wanted to show them because you could see them if you look at somebody else's code. If you want to learn more about these operators, I highly recommend checking them out on w3schools.com. I'll be sending a link to that after the course. I just wanted to show these as, you may see them, but don't worry about them. They're super complicated and extremely rarely used. These are like bitwise and bitwise or, and it gets really complicated. I never use them. I've never had to use them. I've never seen anybody actually use them. I just want you to know that they do exist. So you might see them, but chances are you won't. Cool. Can we have a case where X is a reference number and whatever we do, it will not change? Can we fix it? So that's a great question. Typically, if you have a constant, so in that case, we have a fixed number is typically called a constant, right? So typically the way we do that in any sort of programming language is you make that variable all capitalized, because that kind of calls out, do not modify this variable, it's a constant. Python doesn't have a great way to enforce a constant, but other languages do. And now that I think of it, there's got to be a way to enforce that constant, but the best practice that people generally follow is just to put your variable in all caps and then make sure you don't do any reassignment on that variable from that point on. If you ever see a variable in all caps, that means you shouldn't modify that variable. But there's got to be a way. I think there's a const keyword that you can use to create a constant. I'll have to look into that and get back to you. Great question. But yeah, I hope that helps a little bit. Just if you have a constant that you don't want modified, put it in all caps for now, and then just know, keep in the back of your mind, if you see a variable in all caps, never reassign a value to it unless you have a good reason. Great question. All right, so on to comparison operators. So the double equal sign, its description is it's equal, and here we have x equals y. So what we're asking here is x equal to y, essentially. So that's what the double equal sign operator is for. We're trying to compare x to y, and we're trying to determine equality. So this is our equality operator. Remember, a single equal sign will be assignment. Double equal sign is the equality operator. So we're trying to figure out, is x equal to y in this particular case. The next one here is not equal. Exclamation equal sign, that means not equal. So here we're trying to determine, is x not equal to y. So oftentimes in most programming languages, you'll find that the exclamation point means not. Here we're just saying not equal. Exclamation equal is just not equal. So in this case, if x isn't equal to y, then it'll evaluate to true. And note that this whole column here, every single one of these will evaluate to a Boolean value, just to kind of bring it back to the core data types that we're learning about. So this operator here, the like arrow operator with it opening to the left, that's the greater than operator. So is x greater than y is basically the question we're asking here. We're trying to determine if x is greater than y. So this is the less than operator, that arrow with the opening to the left, like if you look at it like a mouth opening to the left, less than operator. So is x less than y? And then greater than or equal. So if you also care about whether or not they're equal, you can use greater than or equal. So is x greater than or equal to y in that's the greater than or equal operator. And then less than or equal to is x less than or equal to y. Note that when you're doing greater than or equal or less than or equal, you always need to have your greater than or less than symbol before the equal sign. You can't flip these two. And same goes up here. You can't flip these. They need to be in this specific order. So for not equal and for greater than or equal or less than or equal to, you need to make sure that they're in this particular order. The equal sign will come last. Cool. All right. So if there are any questions on that, please throw them in the chat. Otherwise, I'm going to go on to the next slide. Now we get to logical operators. So logical operators are basically ones where you can determine, logic. It's and or not are our core logical operators. So the and operator, its description is that it returns true if both statements are true. So here we're asking, is x less than 5 and x less than 10? So this is now a larger Boolean expression. Remember, like, this is an individual Boolean expression. X is less than 5 is a Boolean expression. X is less than 10 is a Boolean expression. And now we've created an even larger Boolean expression by adding the and in there. So in this case, say the value of x is 7. Well, this evaluates to false. This evaluates to true. But since they aren't both true, it will return false because it only returns true if both statements are true. So each thing on each side of the and is considered a statement. So in this case, if x was 7, this evaluates to false. But if x was 4, this would evaluate to true because 4 is less than 5 and 4 is less than 10. So overall, this statement is true. Now the or operator, it returns true if one of the statements is true. It doesn't matter which one. So x is less than 5 or x is less than 4. As long as one of these is true, then it'll evaluate to true. So say our value is 4. 4 is less than 5, so that's true. Or 4 is less than 4. 4 isn't less than 4. It's equal to 4, but it's not less than 4. So this part would evaluate to false. But since this one already evaluated to true, the whole statement, the whole Boolean expression here evaluates to true because only one of them needs to be true in order for an or statement to evaluate to true. And then not is the inverse of the result. It returns true if the result is false. So if you say not x is less than 5 and x is less than 10, so based whatever this evaluates to, it'll be flipped basically. So using our example of 7, so if x is equal to 7, then is 7 less than 5? No, so that's false. So since both of them can't be true at that point, we already know this is going to be false, but then we not that, and that flips it. So now it's true because the not is just basically taking the inverse of whatever result you got previously. But say, x is 4. So 4 is less than 5. So that's true. And 4 is less than 10. That's true. So this whole statement evaluates to true inside the parentheses. But then since we apply not to that whole statement, it ends up evaluating to false. So this is a way that you can, flip the value if needed. There are a number of cases where you might need to use not. We'll see examples of that in time. But logical operators are extremely useful when you're trying to chain together Boolean expressions and stuff. It sounds like there might be a question. All right. If there are no questions and you're not on mute, could you please go on mute? All right. And feel free to ask questions in the chat. And if you do have a question, you can also come off mute and just ask directly. I'm really liking how the chat approach is going because then I can finish the slide and then answer the question. But feel free to come off mute and ask the question if you feel more comfortable saying it instead of typing it. All right, so on to the next slide, identity operators. So identity operators, there's two identity operators. So returns true if both objects are the same object. So this one gets a little complicated here. Basically, we want to know, are X and Y the same exact object in memory? So if X and Y are both a numeric value, if they're both 5, then X is Y because they're both 5. So that'll evaluate to true. This gets a little more complicated, and we'll talk about it in future weeks when we get to data structures. But it gets more complicated with data structures because you can have a data structure where all the values in the data structures are equal. So the equals operator, the equal to operator, or the equality operator will evaluate to true, but the is operator will not because they aren't referencing the same exact object in memory. The only way that it would evaluate to true is if they were both assigned to the same value. Like say you had X equals some data structure and then Y equals X. Now X is Y does evaluate to true. We'll see that in the future. Don't worry too much about it right now. Just know that these operators exist because you will see them in future weeks. And then same with is not returns true if both objects are not the same object. So X is not Y. It's basically the same thing as using the not operator on is, except you do is not instead of not is. It makes a little more sense to say is not. So that's why it's its own operator. Is not is its own operator. We'll dig more into these in future weeks, but just know that they exist because you will be working with them in time. And again, any questions, please feel free to ask them in the chat. I've been loving the questions so far, but for now, I'll just move on to the next slide. Bitwise operators. We saw these on previous slides. Again, you're almost never going to use them. They get pretty complicated. You get into binary, basically, at this point. I don't know if anyone might be familiar with binary, but all computers at their base level, they're evaluating everything as strings of bits or ones and zeros. So binary is just that format, ones and zeros. Everything's ones and zeros in a computer. You can operate on those ones and zeros if you have a deep understanding of how those ones and zeros are operating inside of your program. So you can, with like these operators, they all operate on the bit level. I'm not going to spend too much time on this slide. I just want you to be aware that these exist and have a reference should you see them in the future. But we're not gonna. You're likely never gonna see them. I've only had to use these once or twice in my entire career, I guess, of knowing how to code. So extremely rare that you'll need to use them. Just know they exist. If you ever get down to like a machine code kind of level, they may be useful. But I just want you to know that they're out there. And if you do want to read more about them, W3 Schools is a great place to read about them, and we can talk more about them. I'm happy to talk about them, but just in the interest of time, we won't spend too much time here. Great. So that's it for the slides today. So there are a number of exercises that I've given here. These are links to w3schools.com. W3 Schools is a great way to learn how to code, especially anything related to Python, CSS, JavaScript, or HTML, basically any web development type tool. W3 Schools is a great place to learn, but they have tutorials and all that stuff on their website, and they have exercises that you can try. I cannot recommend trying these enough. These exercises will help a ton in understanding what's going on here, because you'll actually you'll be challenged to think about the solution, and it'll walk you through the answer if you're struggling with it. To the questions in the chat about, are these links going to be communicated, and can I please share the slides? Yes, absolutely. In the follow-up email when I send out the assignment and the recording of the lecture, I will also share a link to the slide deck. So you will have these slides for reference. And if you ever have any issues accessing them, please let me know. But I won't be sharing them until we get to the point where when I've actually uploaded the recording of today's lecture. So So just please be patient. It takes some time to process and upload these videos because they're so long. And I try to upload them in a higher quality so that you do have the option to select HD and actually be able to read the slides if needed. But, you know, I should get these links to you no later than tomorrow. But yes, the whole slide deck will be available, and you'll be able to follow these links and everything using that slide deck. All right, so let's go over the assignment details for assignment 2 just before we call it for the day. So the assignment this week, and again, this will be in that email that I'll be sending out. You'll have the link to the assignment to get started on it. This one I might send out a little earlier, just for those of you who might have time today and want to get a jump on it and don't want to wait until tomorrow. I'll send it out. So for this assignment, you're going to be creating a basic financial state calculator. So your client wants a program to generate a basic financial report that users then can run regularly to understand their current financial state. That users can, let me edit that. That users can run regularly to understand their current financial state. The program should be able to store the user's name, checking account balance, savings account balance, investment account balance, total utility bills, total credit card debt, credit card balance due, credit card minimum payment due, annual credit card interest rate, loan debt, loan payment due, annual loan interest rate, and other asset value. So it needs to be able to store all of this information. Hint, you'll want to use variables. Something that I didn't mention in the slides that I should have. Anytime you're using a variable, make sure that it's clear what's being stored in that variable. Try to don't give it like variable names like A, B, C. I was using X throughout the presentation because those values didn't necessarily have a meaning behind them. But in this case, where you might be storing a checking account balance, using the variable name checking _ balance is a great way to know what you're working with there. Because if you just have A, then later down the line, from a readability perspective, you come back and you're like, what does A mean? Then you have to read through all your code to understand what A means. But if you give it an informative variable name, you'll be good to go. But yeah, so all these things need to be stored in variables, and then when run, the program should generate the following report. Hello, user's name, the total dollar value of assets you own is, and then the total value of all their assets. Total value of your debt is currently total debt. Therefore, your current net worth is, and their total net worth. Your total bills due are the value of your total bills due. Once you make these payments, you will have the value remaining in the checking account after making payments, and left in your checking account, and total remaining money in bank in your bank overall. Additionally, your total credit card debt will be down to the amount after paying their balance due, and your loan debt will be the amount left on your loan after interest is applied and on the remaining balance for the month, including interest applied on the remaining balance after your payment. Therefore, your total debt will then be paid down to, and your net worth will be blank. So basically here, what you need to do is you're going to need to, create these strings, use the print statement and all that stuff that we talked about last week. And you're going to do various calculations to get these numbers. Anything that's in the angled brackets, you're supposed to substitute in a value in your program. So yeah, and then just get it as close to all this as possible. I got some feedback in the last term of the course that the math that is required here is a little too complicated, especially since we're trying to learn how to code. So while I'll send out the assignment relatively quickly for you all to get started, I will also send out a formula sheet for how you can calculate all of these values, and then you'll use that along with your operators and print statements and such to create this program. So the expectation here is that you're going to create a Python file in PyCharm. It needs to be runnable, and I need to basically be able to go in and insert whatever values I want for all of these variables, and then your program will print out this financial statement. One thing that I thought the slides covered, but I guess that I wanted to mention is the concatenation operator. So plus is can also be used as a concatenation operator. So if you have two strings, say I have hello. So let's say we just have greeting equals hello, and I'll capitalize it. Hello, comma space is the greeting, and then name is, David. Then you can use the plus operator to concatenate these two together. So concatenation is combining two strings. So hello, David. Yeah. So just know that you can use the plus operator for concatenation. And yeah, so let me quickly go over some things from the slides. If you need to get going, this will all be uploaded to YouTube. I just want to go through the slides and give you some examples of all of the things that we've discussed today, because I had promised I would throughout the lecture. So so here we'll just go to future slides. So Booleans, okay, Booleans. Let's just go over this real fast. So if I have 5 greater than 6, what happened here? 5 greater than 6. See, that evaluates to false. So it is evaluating to a Boolean value, like I showed in here. If I stored, x equals 5, y equals 6, and then I do x equals y, that evaluates to false because 5 and 6 are not equal. So this is showing some variable assignment and then operating on them with a Boolean expression here to get a Boolean value. Cool. So already showed some of that here, but if I wanted to assign x and y on the same line, I can do that. X equals 5, y equals 12.0. Can't assign to literal. Oh, it's not liking my single line assignment in the environment here. So careful with the single line assignment. I guess it doesn't work in the REPL environment. It can work in your stuff up here, but it's probably like I said, it's best not to do that. It's way more readable to assign like this. So a question in the chat is, when do we use the Python console window and the project window? Great question. So the Python console is for practice. Use the Python console for practice, or just like examples, or making sure some code works. Something you can do is always type out your code up here, copy and paste it into the Python console, and then hit enter, and it'll evaluate all that code for you. But if you want anything saved, and for the assignments, you're going to want to use a Python file, like up here. Use the file, but when you're practicing or making sure something works, use the Python console. Hope that helps. All right, so I know, I hope everyone has a good handle on most of the operators except for modulus. I just want to show some examples of the modulus operator. So if I do 5 mod 7, that's going to evaluate to 5 because 7 is greater than 5. So we end up with the number on the left, like with the question that I can't remember who had asked previously, but yeah. But if I do, 5 mod 2, since the remainder of 5 divided by 2 is 1, we get 1 out of that. But if I did 10 mod 2, we get 0 because 2 fits evenly into 10, no problem. Say I have this random number and I want to know if it's divisible by 5. It's not. There's a remainder of 2 because there's a remainder left. But if I take that same number and mod it by 2, it is. So this number is divisible by 2. So just, that's one of the use cases there. So if we take this large number and divide it by 5, we get a decimal here. And because 5 doesn't evenly fit into this number. But if we take this and divide it by 2, we still get a decimal, but it's just a 0 decimal. Cool. All right, so that's the modulus operator. And then, so a question in the chat, I don't remember dozing during the last session last week. The assignment doesn't resonate to me. I'm not sure I'm following your question, but if you do, if so if it's not making sense to you, please just ask like, you know, some specific questions about what doesn't make sense. Um, but basically, what I'm gonna want you to do for the assignment is like you're gonna create variables, and then you're gonna create strings, and you're gonna use all of these arithmetic operators, except for like modulus and stuff, to complete the assignment. Um,
Hello, can I just interrupt?
yeah.
Hi. Okay, what I want to say is you came up with a full story that we're supposed to work on. I mean, on your I mean the how do you call the document? Yes. And you want us to replace so many things in there. How do we do that when you're only giving some numbers and figures?
Yeah, so you know, believe it or not, you do know everything that you like. I've showed you everything that you need to know to get this to work. So I can just show like you know, a very basic example here. Like, say we want to just store someone's name. So like, user name equals. So my name is David Sciacca. So we have my name, and then let's just come up with the number, checking account balance. Let's just say 500. So then I could easily, you know, print out like print hello, and then using the concatenation operator, user name. You have, and then you know, checking account balance in your bank account or something like that. Let's put in a dollar sign there. Oh, and one thing I forgot to mention. Thank you for the question. This is why we ask questions. So the stir operator. This is, you can use the operators mentioned in here to or the functions, the built-in functions, to cast a value to another value. So I can cast this checking account balance. Since it's a number, I can cast it to a string using stir, and then, you know, I can do that right there. Hello, David Sciacca, you have $500 in your bank account. So, you know, using all of the information that's in these slides, and then that last little tidbit of using string that I forgot to mention, so thank you for your question, that you should be able to complete the assignment, because you know how to assign variables. You can operate on those variables using all of the arithmetic operators, and then you know how to use the, we talked about the print statement from our last lecture. So you should be able to do everything that's mentioned in the assignment. I know it does seem like a lot, and it seems kind of over your head. If you have any questions on it, please do ask. You know, like I've said before, programming is hard, and the learning curve is very hard. You will struggle with learning how to code. I guarantee it. And these assignments are meant to be challenging. You know, we only have a few months of learning together. I want you all to get the most out of it. So it will be challenging, and I will give you the formulas for calculating all these things. But yeah, so you should be able to, with everything that we've gone over so far, you should be able to get to a successful completion of the assignment. So after writing the codes, how do you run the program? So if you write it in the file up here, so first off, make sure it's a .py file. You need to make sure that the file extension is a Python file extension. You can right click on that file, and then in here you'll see a run option, and then you just click run, and it'll run it down here in the console. Another option that you can do is you can just copy and paste all that code and paste it into the Python console, hit enter, and it will run your code there as well. I hope that helps. So yeah, let me see. And then the last thing I wanted to show is the plus equals operators, because I know there were some questions on that. So let's just kind of go through this slide like I had showed before. So, we start out with x equals 5, right? So now if I want to do x plus equals 6, now we evaluate what x is and output that. We get 11 because I added 6 to x and assigned it back to x. So yeah, now we can do x minus equals 2 and then evaluate what x is. Now we're down to 9. And we can do x times equals 2. And now we evaluate x again. We get 18. Something else you may have noticed over here is that all of my variables in the REPL environment, they're all going to show up in this window over here to the right. So that's super helpful. And then if we do x divide equals 2, now you can see x changed to 9, but now it's a float because divide equals uses it's like a float division instead of integer division. Modulus equals, so let's do x mod equals 2. We're going to get 1 left over now because 9 mod 2 is 1. Assign that back to x, and then x floor division equals 2. Now x is 0 because since it was already 1 and then we floor divided it by 2, we end up with 0. And then if we do x exponentiation equals 2, it's still going to be 0 because of x being 0 initially. Anything 0 to any power is going to be 0. So but let's say we had x equals 5 again. So then I can do, in that case, I can do x exponentiation equals 2, and now x equals 25. So hopefully that helps a little bit with the understanding of those arithmetic assignment operators. Yeah. So I know that's a ton of information. I know it can be quite overwhelming, and I know it might feel like you don't have everything you need to know for these assignments, but I have spent a lot of time trying to get these assignments to a point where they're going to test everything you've learned in the lecture during the day, and it's going to be quite challenging, but you do have all the information you need. So if you do have questions on it, or if you're struggling with it, first off, I highly recommend just reviewing the lecture on YouTube after I upload it. That'll be super helpful to you. But also don't hesitate to reach out with questions, or better yet, ask your questions on the YouTube video. Remember, if you have a question, chances are somebody else in this room has the same exact question. And if you ask it on the YouTube video, then somebody else, who's going through the video and they're like, this doesn't make sense, he didn't explain this well, or whatever, then they can go to the YouTube video and read through the comments and they're like, oh, okay, there's the question that I had, and David's already answered it on the YouTube video, so now we're good to go. So and it's a way to start a discussion, right? So if you have any questions, please ask them on the YouTube video, but if you don't feel comfortable with that, feel free to email me, Raj, and Gaurav directly with your questions. Please do include all of us on those emails because I'm not always available and they might be able to answer a little faster than me. So that helps me out a lot if you can include all 3 of us when you have any questions or anything like that. And yeah, and there may be things I missed. If you are looking through this and you can't figure out how to get this to work properly, and you think there might be something I didn't mention, that's perfectly possible. Like Patricia had that question about like, I feel like we don't know everything we need to know. And then as I was going through the assignment, she was totally right. I did not give you the little stir tidbit that you needed to know for casting an integer value to a string. But also the internet's your friend. Ask questions to Google. You'll learn a lot doing that. I know a number of students in last term had Googled a number of questions they had, and they were able to learn things that we didn't go over in lecture simply because we didn't have the time. But there's no problem with doing that. No problem with asking questions on the YouTube video, and no problem with asking questions to me, Gaurav, and Raj directly. We are here to help you, but we can't help if we don't know that you have a question. So please ask. Great. So I will send out the assignment details here shortly. and I will send out, I'll send out the assignment details and the slides here momentarily. I will upload the, could you please highlight what needs to be worked on the Google Sheet? Can you elaborate on your question a little bit?
What I want to say is the things that we need to work on, like hello user's name, if you can highlight maybe in yellow so that we can straight away have what we need to do.
Oh, like this is your, like highlight this as the output?
Yes, then from what I'm gathering, it's like we're supposed to work on the things that are in quotes, right? Quotes or signs, I don't know what you call them.
Yeah, yeah. So this
Hello,
is, so you're supposed to basically generate this entire output. That's a great point. Yeah, I'll highlight this. I'll give it some sort of background, so it's like this is clearly what the output of your program is supposed to be. Yeah, thank you for the feedback. I appreciate that. Awesome. Yeah, so I'll make sure to like highlight everything that's, you know, part of the program, or so this will be like part of your program, but this is the output that you want to generate. I'll definitely give that a background so it's more clear that this is the output you want to generate. And then remember one other thing with the assignments, just submit them. So if you're struggling, just submit where you're at. If you submit where you're at on the assignment, that helps me a lot in knowing like suggestions for next steps, and it also gives you your first attempt. Remember, if you get a first attempt in before the next lecture, then you get an extra week to work on the assignment. So if you submit your first attempt before lecture next week, then that means you get until the following lecture, so until lecture 4 basically, to complete this assignment. So even if you feel like you haven't gotten very far, just, you know, get something out there and submit it, and I can give feedback as you go. Yeah. Awesome. So thank you all so much for joining today. I hope that you all have a great rest of your weekend and an awesome upcoming week. I'll send out the assignment details and slides here momentarily, and then I'll follow up with the YouTube video once that's uploaded and ready on YouTube. So, and one other thing, all of you who joined today, you do get participation credit automatically. You don't need to comment on the YouTube video, but if you have any questions, please do. Just remember that if you do miss in the future, there are, in order to get participation credit for a lecture, there are certain requirements that you need to comment on the YouTube video and everything. And I have been keeping track of attendance and everything like that. So great. Thank you, everybody. I appreciate your time, and we will talk next week.